And now we're going to be talking about specifically the ceiling and the roof. So as far as air sealing is concerned, hard covers or draft stops shall be placed at ceiling level over all drop ceiling areas, interior wall cavities and chases and double walls bump outs to keep insulation in place and stop air movement to and from unconditioned space. If hard covers or draft stops are missing or incomplete, they shall be completed before insulation is installed. So in the picture that you're looking at here, you're basically looking at a chase and probably some kind of wall, whatever it may be. You can see the top of that chase is completely blocked off and sealed with plywood. The ducts go through it, and that flue go through it as well. So obviously they haven't been sealed properly yet, but nonetheless you can see the draft stop is there. Fire caulking would be used to seal the flue to the actual draft stop itself. Any penetration cut into the ceiling are sealed through the surrounding drywall. This includes, but is not limited to, electrical boxes, fire alarm boxes, fire sprinklers, HVAC boots, and exhaust fan housing, including all holes and seams in the housing itself. If you're dealing with an unvented attic, in unvented attics, there is a continuous air barrier at the roof, deck, and gable ends. All penetrations must be sealed. So if you're working in a house that has an unvented attic, the whole attic has to be completely sealed from the outside of the house. And again, just like we talked about it for the walls, I mean, also for sealing a roof, insulation shall be correctly sized to fit snugly as sides and ends. You want to minimize voids and gaps. Insulation shall be installed to be in contact with the air barrier, and that's going to be also gapped through the ceiling or hard covers like we talked about earlier. Insulation shall be applied all the way to the outer edge of the wall top plate and flush against any ventilation dams or baffles. Rigid board insulation installed above the roof deck shall be applied to the outer edge of the plane of the top wall plate. Obviously, because you want to extend the insulation the furthest out as possible of the house. Batten blanket insulation that is thicker than truss depth shall be installed so that the insulation expands to touch a joining cavity over each truss member. And as you can see right here, you can see batt insulation that's just spread over the actual trusses. You cannot see the trusses because the insulation, the batt insulation, is covering them completely. For compression, where necessary, batt and blanket insulation shall be cut to fit properly. There shall be no gaps, nor the insulation be doubled over or compressed. When batt and blanket insulation are cut to fit a non-standard cavity, they shall be snugly fitted to fill the cavity without compression. Batt and blanket insulation shall be cut to butt fit around wiring and plumbing or delaminated so that one layer can fit behind the wiring or plumbing and one layer fit in front of it. In the picture on the right hand side, obviously you can see how that is not done the way it was just described. So you basically have the insulation just laid over the piping and wiring, which is obviously the wrong way to do it. So that would be a fail. Baffles shall be placed at the eaves or soffit vents or vented attics to keep insulation from blocking eave ventilation and prevent air movement under the insulation. The required net-free ventilation area shall be maintained. So the baffle, again, does two things. We talked about this during the Title 24 overview section. The baffle keeps insulation from covering the vents, but at the same time, it keeps the ventilation from the vents from disturbing the insulation, mainly in the case of loose fill insulation. So nonetheless, baffles have to be present, and the insulation cannot block the actual vents. Recessed light fixtures shall be rated as insulation contact and airtight, IC and AT. They shall be sealed with a gasket or caulk between the lights housing and the ceiling. Insulation shall cover all recessed lighting fixtures to the same value as the ceiling. If not, an area weighted calculation is required. And again, for chimney and flue baffles, insulation shall be kept away from combustion appliance flues and chimneys with sheet metal flashing. 1-inch distance for double wall flues and 6-inch for single wall, or in accordance with the flue manufacturer installation instruction or labels on the flue. The flashing shall be sealed to the surrounding framing with fire-rated caulk. And you can see the picture on the right hand side. They're building a dam or a baffle around the actual flue in order to create that. In this particular case, looks like a 1-inch space of distance, so that the installation stays away the proper distance. Once the actual baffle is installed, the installation will be in full contact with the flashing, and the collar must be at least as tall as the depth of the installation, as you can see on the pictures on the right hand side. Obviously, you don't want the baffle to be lower than the level of installation, because then the installation will just fall into it. Now, when inspecting blown-in installation, there have to be attic rulers appropriate to the material, and they have to be installed and evenly distributed throughout the attic to verify the depth of the installation. The rule is that there has to be one ruler for every 250 square feet, and they have to be clearly readable from the attic access. Attic rulers shall be scaled to read inches of insulation and the R value installed. So you're going to find these rulers throughout the attic to basically verify that the installation being installed meets the inch per R value requirement. For blown installation, installation shall be blown to a uniform thickness throughout the attic, with all areas meeting or exceeding the installation manufacturer's minimum requirements for depth and weight per square foot. So the installation, when blown in, has to be somewhat even throughout the attic. It cannot be big waves. The picture that you see right here is a very good example of what blown in installation should look like in an attic. You can see the attic ruler is installed as well. So how do we measure blow-in thickness? The Hertz rater shall verify that the manufacturer's minimum insulation thickness has been installed. For cellulose insulation, this verification shall take into account the time that has elapsed since the insulation was installed. At the time of installation, the insulation shall be greater than or equal to the manufacturer's minimum and initial insulation thickness. If the Hertz rater does not verify the insulation thickness at the time of installation, and if the installation has been placed in less than 7 days, the insulation thickness shall be greater than the manufacturer's minimum required thickness to achieve the given R value at the time of installation, less half an inch to account for settling. If the installation has been in place for 7 days or more, the installation's thickness shall be greater than or equal to the manufacturer's minimum required settled thickness to achieve the given R value. The Hertz rater shall verify that the manufacturer's minimum weight per square foot requirement has been met for attics insulated with loose fill insulation. Verification shall be determined using the methods of the Installation Contractors Association of America, or ICAA, Technical Bulletin number 17 or 33. Only one sample shall be taken in that area that appears to have at least the amount of insulation. The rater shall record the weight per square foot of the sample on the Certificate of Verification, or CF3R. So the first thing that we want to do is you want to press the coring tool, also called a cookie cutter, into an insulation to its full depth. You want to try to avoid electrical wiring, plumbing, framing, and any other obstructions. So try to go into an area where it's going to be completely flat at the bottom of the insulation with no obstructions. So on the pictures on the right hand side, you see the coring tool, and the picture at the bottom, you see the coring tool was pushed all the way at the bottom in full contact with most likely was going to be the ceiling, the ceiling drywall from the room below. You will then want to remove the insulation with the sampling tool and place it in a separate container. So you place the coring tool in the insulation, and then you take the insulation out of the coring tool while leaving the coring tool into the actual insulation itself. You want to tear the scale with the empty sample container on it, and then you want to weigh the sample of insulation. You then want to divide the weight of the sample by the area of the coring tool in square feet. Once you calculate your pounds per square foot, you will then be able to compare that particular number to the actual manufacturer specs that's going to tell you the actual R value for that insulation. So the label that you see here, by the way, it's only a sample. This label is for example only. Each product will have its own unique specification based on the manufacturer, but it's just to give you an idea on how it works. So if you look at the fourth column down on the label, it says the minimum weight pounds per square foot. If you go 2 slots down, it's going to say 0.338. So if that was the weight that you calculated off the scale, that would tell you is an equivalent of an R19, as long as there's at least 7 inches worth of insulation on there. And again, keep in mind, this label is only for example only. You would not use this label for all products. You would use this product specific label for whatever product you're measuring. So the measured weight per square foot or density must be greater than the manufacturer's specifications required to achieve the target R value on the CF1R. So if the R value that you verified then matches or exceeds what's on the CF1R, you pass this particular verification. For enclosed rafter ceilings, an airspace shall be maintained between the insulation and the roof sheathing per California Building Code, Section 1203.2 and R 8065.23, or as specified by the local building department. So you can see in the picture on the right hand side that there's about a 1 inch gap, what it seems to be at least, between the actual insulation and the roof sheathing. So this would be an example of cathedral ceiling, or as the slide says, an enclosed rafter ceiling. So as far as special situations for attics and cathedral ceilings, in unvented attics where insulation is applied directly to the underside of the roof deck, all gable ends shall be insulated to the same R value as the exterior walls as specified in the compliance documentation, CF1R, CF2Rs. In unvented attics where SIPs are the insulated roof structure, all gable ends shall be insulated to the same R value as the exterior walls as specified in the compliance documentation. Again, the same forms we just mentioned a second ago. For HVAC platforms, insulation shall be placed below any platform or catwalk for HVAC equipment installation and access to the same value as the ceiling insulation. Insulation shall be installed so they will be in contact with the air barrier, which is going to be the drywall. If not, an area weighted calculation is completed and turned in with a CF3R EMV23. So on the picture on the right hand side, you can see that there is insulation under the HVAC platform, however, it's highly compressed. You can see the sides of the framing members below the platform itself. So you know that once the drywall goes in, that insulation will not be in contact with the air barrier, and that's why that will be a fail. For attic access, you want to permanently attach rigid board insulation, bat or blanket insulation with the same R value as the ceiling to the access door using adhesive or mechanical fasteners. The bottom of the attic access shall be gasketed to prevent air leakage of conditioned air to the unconditioned attic. Vertical access requires mechanical compression such as screws, latches, or doors. The attic access must be surrounded with a dam at least the same depth as the insulation to prevent loss of ceiling insulation when the access is open. So now let's look at some pictures. So in this particular picture, you can see that that would be a fail for some kind of draft stop, right? You can see the giant gap on the side of the duct. That should be sealed properly if that was an actual hardcover. So that would be a fail for the purpose of that hardcover or draft stop. They would have to plug that hole somehow and seal it properly to be defined as an air barrier. Now this is an example of a good draft stop. Obviously it's sealed all the way around. It's keeping the insulation from coming down. On top of that, you can see the flue going through the material, and you can see that it's gasketed properly, and it also has a baffle to keep the flue away from the metal itself. Obviously, we would have to verify that behind that flashing, the flue is actually not in contact with combustible material, but nonetheless, from this angle, from this picture, it looks like it would be okay. Compression in ceiling insulation, obviously you can see it's wavy, it's compressed. Once the drywall goes in, it will not be in contact with the drywall, so this will be a fail. This is a very good example of well-installed blown-in insulation. It's even all the way around. Obviously, this would be a fail. We talked about delamination and compression. Obviously, they haven't done any of that in this particular installation. It looks like they just laid the bats over everything else. So in this particular scenario, this would be a fail. This shows a little further detail when we talked about flashing chimneys and flues earlier in the PowerPoint. So basically, there's a step-by-step process to show you how they would have done it in this particular scenario. You can see that the framing material on the left-hand side picture is not touching the flue. They're putting flashing around it. Then they're going to seal it up with high-temp silicone, and then they're going to put an additional baffle around this so that once the insulation is actually pressed against it, it's not going to come in full contact with the actual flue. And this is an example basically opposite of what we just talked about. You can see the insulation is in full contact with a combustion vent of some type, so there will be a fail. That's a fire hazard. This is an example of a attic ruler installed before the actual insulation goes in. You can see that the bottom of the ruler is installed flush to the bottom of the truss. That's the way it should be. And one thing to point out is make sure that they are actually installing these rulers correctly. It does happen, and we've run into it in the past, where some installers try to cheat the system and basically raise the values by basically cutting the ruler shorter. So either by folding them or actually starting them lower than the bottom of the truss. Obviously, it's going to make it look like the R value is actually higher than what it is. So verify not just that the rulers are there, but they're actually being installed properly and you're reading them properly. Another bad picture of insulation, nothing but gaps in compression, bad all the way around. It's pretty self-explanatory. This will be a fail.